Welcome to Viking Aircraft Engines, and today we're going to talk about testing. Viking Aircraft Engines, as you know, make aircraft engines based on automotive engines. So how does this all start, and how are we testing these engines to make sure that they're thoroughly tested before a customer is flying one of our products? Well, we have a long track record, first of all. I've been doing this for 30 years, Jan Eggenfellner. In the beginning, learning a little bit, having a couple of failures, mostly with me in the plane, and then as time went by, I perfected the art of making a car engine fly. And now it is a lot easier for me to design one, but yet we go through all kinds of testing to make sure the engines are what we want them to be when they hit the airplane of the customer, so that they can be safely flying this airplane with themselves or with their friends. So how does this all start? Well, it starts in the computer. We got the knowledge and the experience, and next we take an engine model and we design parts for this engine, and everything is analyzed and stress tested and all that. So we've got not just the engine, but we have the engine mount, which is 4130 steel tubing, all triangulated, stress tested, and so forth in the computer. Then we have engine mounting brackets on the engine. We put that all in the computer, we analyze it, and so basically we have a lot of work that's done before we ever cut a piece of metal and before we ever actually make an aircraft engine. Now, of course, these engines are already tested by whomever we're using as a platform. If we're using a Honda engine, we have faith in that Honda does a really good job of designing engines. The internals of those engines are already proven, so we don't have to go through that, other than every single engine that we do, we have a lot of dyno testing. What does that mean? It means running an engine to the point where you can analyze the internals as far as spark, the ignition timing, the condition of the spark plugs, the effect of variable valve timing, the effect of different amount or lack of cooling on that particular engine model, and the design of the wire loom, the ECU, the electronic control unit that runs that particular engine, and the software that goes into running that particular engine. So countless hours are spent on perfecting that part of it, even though in most cases we have an almost identical engine running next to the one that's being developed. And where do we go from there? Well, once the engine, the prototype engine, is put together and it's been test run on dyno, we take it to the level of running it with a propeller on a ground-based aircraft. Once we do that, we can run it all the way up to load, all the way back down to idle. We can do this for hours at end, and we can change the pitch of the propeller in order to visit all aspects of where this engine would be normally running if it was flying through the air. The next thing that happens, obviously, all little bugs are worked out, analyzed, improved upon, and fixed. And then me, Jan Eggenfellner, fly all these engines on their first flights and the first hundreds of hours. Sometimes I end up being lucky enough to have a customer, just like Rotax does, for instance, and other companies, that are willing to build some hours for us. No different than anyone else that wants to test something and get a lot of hours quickly. You would use a volunteer pilot that is a competent pilot that wants to have an early adaptation of the engine and are flying a lot. So it's a shared experiment between myself and other pilots that are flying these engines. We build up hours quickly before anyone that are actually receiving engines later are ready to fly. Clearly, we don't want to take years to do this. We use the latest in automotive technology. So when we work on a 2024 Chevy Trax engine, we want people to actually get one in 2024. So it has to be worked out in a safe and effective and efficient manner. from design to finish. And that's what we do. Now, once in a while, we'll get a test pilot, not an official test pilot. Nobody here is an official anything. I am self-taught. I am a certified pilot. I have multi-engine, land, instrument, commercial, all that. Sometimes we'll get someone that is a private pilot that wants to fly and build hours. Sometimes we're reluctant to maybe even suggest that a low-time pilot would do this, but a low-time pilot can also be experienced enough to do this. But most of the time, these are highly trained commercial pilots with thousands of hours flying all kinds of airplanes. We do like to see all the testing within the parameters, or it's not really testing at this point because I did that. It is time building. And we like to see all that time building taking place inside the parameters that I set during my initial flying of that particular engine. That would be no more than a certain temperature, no more than a certain RPM, no more than a certain RPM for extended period of time. If you're flying a variable pitch propeller, there's no need to explore the absolute maximum RPM or the absolute minimum RPM. Most pilots understand that a normal range that is within the parameters of the engine, the airplane, the safety of everyday flying is where you want to be. You don't want to be a race pilot. You might not want to fly as cheaply as possible. You don't want to do oil changes at 100 hours if 30 or 40 or 50 is recommended. And you don't want to exceed any of the parameters. If someone says use 93 octane fuel or 89 octane fuel, don't be flying with 87 octane fuel. And if you consult the factory and the factory says, well, we probably could fly with 87 if we retune the engine for 87, but you will have less power. And why would you want less power out of an engine just for a few cents an hour? So, yeah, but the other side of it, we're also accommodating. We are a very accommodating company. Somebody wants to have a little extra RPM because they're on floats or a larger diameter propeller. We will work with them and we will continue this testing as a team with this customer. Like, yeah, let's do it within these parameters. Somebody wants to fly 87 octane. Yeah, well, don't go out and fly 87 octane first and maybe burn up a plug or two. You know, let's get together and put the 87 octane in and use all the available design features and all the test equipment like NOx sensors and laptop to actually monitor the engine and so forth while we're doing this. But it's too late once it's been done. If you're already flown with 87 octane or lower octane and you burnt up a spark plug, it's too late. You've already stressed that engine. So it's a little bit insulting, I guess. I don't think about it because I'm used to, designing the engine, getting in that airplane and making the first flight. And I'm used to offering to our customers that I will do your first flight for you because I believe in the engines that were designed here at Viking Aircraft Engines. But when someone says or tries to say that I have tested the engine more than you, well, it's very insulting. And then if it's like, well, if it wasn't for me, none of Viking engines would ever have been tested because Viking doesn't know how to test. I mean, that's just like, where did that come from? The Viking 130 engine, as an example. Hundreds of hours by Dean Phillips in New Zealand before anyone racked up the hours in this country. My friend up in Carolina, hundreds of hours on his 130 before anyone racked up hours in this country in a Rance S20. So lots and lots of hours being built, experience being built, and then suddenly someone jumps into the hoop and it's like, if it wasn't for me, nothing would be tested at Viking. And this video is a little bit about that, as you can see. It's about someone blaming us, me, for not testing. So I'm just letting you know that there's plenty of testing. There's parameters put in place for your engine, and they're beta flyers that have more hours than you will have when you get your engine. And that's just how it is at Viking.